Well, good morning, everyone. I want to welcome you to the Microsoft Fabric webinar. This is an opportunity for us to share about a product that we're very excited about and think it will bring some great value to your organizations. We're shooting for a 30-minute webinar, so I'm not going to take too long to get things started, and we have a ton of content. Just a couple of housekeeping things. We are recording the webinar, so you can watch it at a later time. And so we'll make that information available to you after the webinar is over. And I will be moderating questions. And so there's a Q&A link in the top of your screen. You are welcome to click in there and type in any questions. They will come to me and I can review them. The way we'll do questions is if I'm getting consistent questions or if I'm getting a question that fits really timely with what's being presented, we'll interject it at that point. Otherwise, I promise you we'll collect all the questions and we'll answer them and we'll make sure and distribute those answers back to you after the webinar is over too. So your question will not go unanswered no matter what happens. If it doesn't get answered in the webinar, it'll be afterwards. Want to introduce you to our speakers today. Brian Larson is Chief Creative Officer here at SCS and also a business intelligence data analytics consultant. And he will be going through the slides and the discussion about the concepts of Fabric. And Brian Garabinowski is Senior Data and Analytics Consultant here at SCS. And he's going to go through a short demo for you so you can see what Fabric looks like and get a feel for how the end-to-end data to visualization process works. So without further ado, I am going to hand the reins over to Brian Larson to let you know how Fabric works and the exciting things to learn about it.
All right, thanks, Paul. I do want to dispel any rumors that you have to be named Brian in order to do data analytics consulting here at Superior Consulting Services. We do have other data analytics consultants not named Brian, but Brian, of course, is the best name, right, Brian? So what we're going to cover today in the webinar, we will talk about just what is this new product called Microsoft Fabric. We'll explore its key functionality. We'll take a quick look at the Fabric environment within Azure. Then we'll talk briefly about why Fabric we feel is going to be important to your organization, and hopefully you'll agree on that. And finally, one of the biggest questions is, what is Fabric going to cost if I implement a Fabric solution within my organization? So that's our agenda. We begin with the question, what is Fabric? Here's Microsoft's definition. It's their marketing jargon. Fabric is data analytics for the era of AI. Well, that's great, sounds catchy, but that doesn't really tell us much of anything. What does that really mean? What Fabric is an end-to-end solution for data warehousing and data analytics, including AI and machine learning. And that end-to-end analytics solution is based in the Azure cloud, a cloud-based analytics solution for end-to-end data warehousing, data analytics, AI solution. Now that all may sound familiar to you. Doesn't Microsoft already have a solution like that? Yes, it does, but it's made up of a number of Azure components that all need to be used together to create that all-encompassing enterprise-wide analytics solution. It is a do-it-yourself, a DIY environment. Prior to Fabric, what we have currently is platform as a service, meaning Azure provides various platforms for us to build on. Azure SQL Server, Synapse, etc. They're made available to us through Azure. but we need a technical team to create and support the environment that puts it all together, to build the pipes between the various items, to build the security infrastructure around it. There are a lot of moving parts with multiple interfaces. So it's hard to, it's hard to determine the cost of the environment at the end. So all those things make the current environment a little more labor intensive to create and to maintain, and frankly also a little more expensive to operate from month to month. So now along comes Fabric to bring all those parts and pieces together under one environment. Fabric includes data ingestion, bringing data in from other line of business systems within your organization, or bringing data in from your flat files or Excel files, other supporting file-based systems, and bringing data in from external sources as well. Fabric provides the mechanism for storing that data within the Azure cloud. It provides a mechanism for data modeling, for creating semantic models on top of that data that's been brought into the environment. It has tools for visualizing and exploring that data, creating reports, creating dashboards, and doing interactive data exploration. And finally, it provides the tools for artificial intelligence and using machine learning against that data to provide those types of AI insights. So essentially now what we have with the Fabric environment is software as a service rather than platform as a service. Microsoft creates and supports the Fabric environment. The functionality is all tied together within Fabric. We have one user interface to configure and monitor all of the different parts and pieces used for those various functions, and the cost calculation is very straightforward. So we can upfront determine what a Fabric environment is going to cost us, knowing a couple of basic factors. So what are the key functions that Fabric brings together? We touched on them briefly, but let's explore or go over them a little bit more in detail. First of all, as we talked about data ingestion. We need to bring data in from a multitude of different sources into our Fabric environment so that we can turn it into meaningful information for machine learning and for analytics. We need a place to store that. In Fabric, that storage location is called OneLake. It is a data lake architecture, and it brings all of that storage under one location. We've got data stewardship, being able to clean that data as it comes into the environment, to be able to keep track of the lineage of that data. What source system did it come from? All of that is available. We want to create semantic models on top of that data to provide business user-friendly interfaces for exploring and reporting from that data. We want to capture business logic in one location, so we aren't duplicating those calculations from report to dashboard to spreadsheet. We want to be able to deal with big data, with streaming data that's coming quickly from those types of services, monitors, and devices that are putting out lots of information very quickly. We can deal with that within Fabric. We want to be able to visualize the data with reports and dashboards. We want to be able to interact with that data, do what-if types of explorations. That's all available within Fabric. And we want to be able to do data science, AI, machine learning, all terms for similar types of functionality. And finally, we're able to do prescriptive analytics where we can set up monitors on various levels of our indicators. And when a level gets too high or too low outside of a normal range, we can trigger thresholds, trigger actions based on those thresholds, excuse me. So
Hey,
all
Brian,
of
I'm going to
that,
briefly interrupt you for a moment. We have a
yeah,
number of people attend a little later after the intro. There's a
yeah.
Q&A section at the top of the webinar. Feel free to type any questions there. I will be monitoring the questions, and we'll either answer those questions during the webinar here, or we'll collect those questions and send the answers out to you afterwards. But feel free to use that Q&A as much as you'd like to. Thanks, Brian.
Yep. Thanks, Paul. Appreciate that. All right. So now let's actually look at this Fabric environment. To do that, we're going to use data from a fictional company. This was data that was created for the books that I authored on Microsoft Analytics and Power BI. That sample company is called Maximum Miniatures. They create figurines. So this is manufacturing and sales information. For the particular example we're looking at today, we're consolidating information coming from the accounting system and from the manufacturing system. The accounting system data is available within a SQL database that we can query. The manufacturing information is coming from flat files that are updated periodically. So once we pull that data into the Fabric environment, we want to create a semantic model on top of that data, and we want to produce analytical output. So in our example, there are data flows to bring data in from the accounting system and from the flat files for the manufacturing system. A semantic model is built within what Fabric calls a lakehouse. In the data lake or OneLake environment. And finally, we have reporting in Power BI. So I'm going to turn things over to Brian Grabanowski, and he will give you a quick tour of the Fabric environment.
Thanks, Brian. Yeah, as Brian mentioned, we're going to do a quick overview of the Microsoft Fabric environment. If any of this is interesting to you, we're going to be doing another webinar in a couple of weeks that goes a lot deeper dive into kind of how all of these assets were created and a lot more information around that. So keep an eye out for that if you're more on the technical side of things. The first thing I'm going to show, though, is just a brief overview of Fabric itself. So I just clicked the Create button in the upper left. This is a list of all of the different products under the Fabric umbrella. None of these products are really new for Microsoft Azure. They were all existing, as Brian said. So Fabric is kind of drawing a new box around all of these products and integrating them in various ways, including billing, which we'll talk a little bit more about. But you can see there's a lot of different things that we can create. Most users of Fabric are not going to need to know all of these. For example, I've been in here for a month or two. I still haven't used Data Activator, haven't used the ML modeling, and some of this real-time analytics. So in an effort to make this a little bit easier for developers to navigate around, Microsoft has these 7 different personas. So we call them personas, but they're really closely tied to job functions, and a lot of those different applications that we just looked at are going to be duplicated across these. So my role at SES is largely data engineering, so I like to hang out in this data engineering persona. We can see here we've got like lakehouses, notebooks, pipelines are kind of the big ones that I use in here. If we want to switch personas, we can just click in the lower left. We get that list of 7 again. So similar to data engineering is data warehousing, just for example. So we can see data pipelines are duplicated between warehouse and engineering, just because there's both closely related job functions. So the personas are how Microsoft kind of organizes the different products that they have. They also give us workspaces, and workspaces allow the end users to organize the assets that they create. So they really allow collaboration, organization, and securitization. So for example, this is the workspace that I created for today's webinar. These are all the different assets that were created that have to do with the demo project. You can see there's quite a few of them, and the reason that we put them all into one workspace is so that the demo webinar products aren't getting in the way of everything else. So you can see here I've got several different workspaces. Some of them are like, SCS has a time off program and some other client stuff. We also have our personal workspaces. So the personal workspace, nobody else can see unless I'm sharing these assets, but it's a spot for me to just kind of work on things until they're ready to be promoted and shared out with other people. So here's the workspace, like I said, that with everything that we created. I'm going to show the semantic model because I think it gives a good overview of the data that we're going to be looking at. As Brian mentioned, the fictitious company that we're looking at has data from two different locations. It's from the manufacturing system, which is this fact table, and then the accounting system, which are all these other dimensional tables. So the first data pipeline that I created is the pipeline that creates all these different dimensional files and loads the data into them from a SQL Server environment. So to come back out to my workspace, I'll look at this data flow. So this data flow was extremely simple to create. All I had to do is connect to a SQL Server environment that was mimicking our accounting environment, check off all the tables that I wanted to copy down, and then set the destination into the lakehouse. I did that for each one of these tables, and then we just hit run. It created all the different dimensional tables and then loads the data into them. In a production environment, we'd probably want this updated on some sort of frequency, like weekly or daily. And all we have to do to get this data to update is hit this refresh button. So that was super simple. As I mentioned, the manufacturing data came from a different location. We'll take a look in our lakehouse right here. So all of these tables were created and loaded from the data flow that we just looked at. Give you a sample of kind of what the tables look like. It's the simple table here. This is the dim country table. The manufacturing data in this sample scenario came in a little bit different format. So we have this coming in CSV. And I have two CSV files. This is the last month of data, and there's another one that looks identical to this, but it's like the last 5 years of data. So to get this to load, we created another pipeline. This one was a little bit more complicated and more probably what we're going to be seeing in production systems. So you can see over here on the right, these are all the different steps that I applied to this CSV file. So the first thing I did was upload it into the lakehouse. Uploading files into the lakehouse is very easy. I'm actually going to fill this step. All we do is get data, upload files, and then just browse and select it, and it gets uploaded into the lakehouse. Now that I'm ready to work with that file, I'll come back out to data flow. And here I'm actually going to be modifying and changing this. So just for example, we got a different set of columns that we needed. They sent us the number produced and the number rejected, but our target file format had number accepted and number rejected. So we came in here and just made like some calculated columns and a couple of just simple calculations. Reordered the columns, hid some, things like that. Once we were done with that, the file matches the output format, and we could just run this data flow. So I did that on the historic file, and I was able to load, the 5 years of data. And then to load the monthly file, all we have to do now, every month we upload a new file and then run this data flow again. And then that will automatically load the data into the Lakehouse, and that new data will flow through to the semantic model. So once our data is all on these tables, we would come in here and do the data modeling in the semantic model, and that is just really creating relationships between all these tables so that the model knows kind of how everything is related. So all we had to do is come in here and, for example, drag product code onto product code. There's already a relationship there, and that's what kind of creates all the relationships within the data model, so Power BI can kind of work its magic. So here's the semantic model. Once we have a semantic model, we can then create the Power BI reports. On top of that, I also created a data warehouse that we could create reports on top of. It's a bit outside of the scope of this call, but it's very easy to, once we have the data in the Lakehouse, to say, okay, now we want to use that to create a warehouse, which opens up some existing functionality. I'm going to turn this back over to Brian Larson as he created the Power BI reports. If anybody has any questions about what we went over, I know I kind of went over a lot of information. Make sure to just ask Paul and we'll get those questions answered.
All right. Real quickly, once we have the semantic model built, we can create a output in Power BI. We've got all of the great interactive capabilities of Power BI. This is simply a Power BI report that is a number of buttons that will take me to additional pages within the report. I've got all of the drill down and analytics capabilities, and that allows me to work with the data within the report. There we go. We can drill down. We can go back to our table of contents here and look at other. I've got a custom tooltip built here within this report. So all of the great interactive features in Power BI, this is the same authoring interface. It is Power BI that we're using to output the data. So why is Fabric going to be important to your organization? Let's take a look here. We're going to look at some of Microsoft's buzzwords that they use to talk about why Fabric is important, and we'll try and decipher those a little bit out of marketing speak. Microsoft talks about no-knobs performance. As we said, this is software as a service. So Microsoft is doing most of the behind-the-scenes tuning and management of the environment. There is artificial intelligence that is tuning the environment for optimal operation. You don't have to have a team of technical folks that is doing the care and feeding of the environment. Microsoft talks about this being lake-centric and open. That means that Fabric has a single storage location called OneLake. You can think of that as OneDrive for your data. All of your data exists in that data lake, and it is stored in a file format, a Parquet format, specifically Delta Parquet, which is an open standard format. That means that it's going to be easier for you to find and hire staff that are familiar with working with that particular file structure. There, Microsoft talks about simplified data ingestion. There is a robust set of tools for pulling data in from files and from relational databases. We also can mirror databases that are stored in Azure with near real-time mirroring, so we don't have to pull that data on a set schedule. We can get that real-time replication through mirroring. There are also shortcuts that will allow us to pull data from existing data environments within Azure, within Amazon, and within Google. So even within other cloud structures, we can use those shortcuts, and we don't have to copy the data into another location. Then once the data is in that one lake, one copy for all computes. What that means, again, translating from Microsoft speak, is that we don't have to copy the data over and over again for different purposes. We use the same data from the Delta Parquet file in one lake for reporting, for doing stream analysis, for doing our triggers, for doing data science and machine learning. That allows security to be applied once and enforced across all those uses. So it cuts down on the storage size and again provides easier administration. So what is this going to cost? Cost is based on two variables within Fabric. One is the amount of compute time that you provision or that you purchase. And second is the amount of storage used within one lake. So compute is measured in capacity units or CUs. These are allocated in powers of 2, so I can purchase 2 CUs, I can purchase 4 CUs on up to 2048 CUs. Each time the power doubles, just as the number would imply as I go up the scale. You purchase these through SKUs within Azure. The F2 SKU gets you 2 CUs. The F2048 gets you 2048 SKUs. Also, there is the ability to go beyond your SKU limit, your computing capacity for small periods of time to handle temporary heavy workloads that come along. And that ability to do that bursting capacity, that burst to a higher level of compute capacity is limited then by the burstable scale. And you can see based on CU, if I purchase the F2 CU, I can have a burstable compute capacity that is 32 times what I have purchased for a temporary period of time. So I'm not tightly constrained by that SKU CU level. How many CUs will I need for my organization? Well, I am a consultant, so I get to say it depends. It depends on the number of simultaneous users that are going to be interacting with that data environment. It depends on the complexity and of the data operations and the calculations being done. It depends on the frequency of the data refreshes that are being done within the environment. In most cases, you'll be able to start with purchasing 2 CUs, and you may find that that gives you enough performance, especially with the burstability, that you never need to go beyond that. So what does that translate to as far as dollars and cents? Within the north central U.S. region that we're in, 1 CU is 18 cents per hour. So for that F2 SKU, that's 2 CUs. If I multiply that per hour rate out, I get about $9 per day, or about $268 per month for that F2 SKU. It's also important to keep in mind that for the F32 SKU and below, you also need to have Power BI licenses, either Power BI Pro or a premium per unit license for anyone who is consuming Power BI content, reports, dashboards, doing interactive data exploration. They need that additional Power BI license, the Power BI Pro, which is approximately $10 per month per user. On the storage side, that is simply the amount of space that's being used within your OneLake storage environment. The average data warehouse tends to be less than 1 terabyte. So if we look at that as kind of a benchmark, that gives us a good feel for cost. Again, in the North Central U.S. region, we've got 2.6 cents or $0.026 per gigabyte per month. So storage is pretty cheap. That works out to $26 per terabyte per month. So putting all of that together for an example here, if we do purchase that F2 SKU, we have 1 terabyte of data, and say we have 10 Power BI users, so we buy those 10 Power BI Pro licenses. That comes out to about $400 per month for that Fabric environment. So that's an overview of Fabric and what it means to your organization, and about some idea of what it's going to cost your organization to put that environment in place. We feel that Fabric is going to be an exciting product by pulling all of those various parts and pieces within Azure together under one user interface, providing that clarity of licensing and pulling the cost of those types of environments down to a more manageable level. All of those things make Fabric a very exciting environment going forward. We're happy to talk with you about specifics of Fabric and data analytics within your organization. We'd be excited to partner with you on architecting and implementing a Fabric solution. We also provide mentoring services to work alongside of your team to help your team learn the Fabric environment as we work together to actually implement a Fabric solution for your organization. And we provide training both for your technical staff and for your business users, which is also important to empower those business users to get the most out of your data as they interact with those semantic models. So if you're interested in further information or partnering with us, please contact Michael Bergstrom, our president here at Superior Consulting Services. His email address is on the slide there. You can also check us out at our website, which is teamscs.com. And we thank you very much for attending today.
Thank you, Brian. Just want to close out the presentation. The reason we are really excited about Fabric is the end-to-end data and analytics capabilities with that just crazy price tag of you could be doing an end-to-end data analytics solution hosted for $400 a month, which is amazing. So once again, we did not have any questions right now, so I won't be doing a follow-up with question and answer sessions, but you're welcome to ask us any questions via email, contact Michael, and we would definitely help you out with any questions you might have. Thanks again for attending, and have a wonderful day. Take care.